Hello, this is the encoder project I was talking about. Basically, a guy in Craigslist had an ad up about a WireCounter feeder that he wanted a digital front end for. He wanted a PLC because he had one lying around, but he didn't have any of the software to program it, and that software is usually not freeware. So I told him I could do it embedded, so I made an example project that did such a thing. Then he wanted me to design the mechanical part of it, and at the time I wasn't that comfortable doing such a thing, and he owned a machine shop. I just wanted to stay out of the mechanical section of it. I figured he could take care of that part, but apparently not. So I found him some just mechanical style counters, just wheels with little tickers on them. And in the end, he ended up going with one of those and not going with my electronics at all, for whatever reason. So I got kind of screwed on that whole thing, but I learned a lesson. So anyway, not to complain too much, I'm going to post the code for this up. What it is a feet and inches counter for wire that you pull through. So there's an encoder back here, right here actually. It connects to this little terminal block up here, and as it spins, your inches and your feet increase. The center button here is for reset, and left and right increase or decrease your PPI. Now your PPI is your pulses per inch. Now your encoder is going to give pulses per revolution, and then based on the size of your wheel, you're going to determine your inches per revolution, and then you get your pulses per inch. So you're basically going to need your circumference and the pulse count of the encoder. This one's 30 pulse per revolution. So let's just say that one revolution is 1 inch. So that'd be 30 pulses is 1 revolution, and that'll be 1 inch. And let's say that up and down actually increase your offset here. So if you have to feed so much in your machine first, you can record that offset, and if you hit this lower left button, it saves it to the EEPROM. So anytime you reset, that value is always there. So let's move forward a little bit here. See how to increment of the feet there. So reset. Also, let's sorry, this thing is a little touchy. The encoder is. So if I lose power and I power up, it resets to the EEPROM set point value. If you wanted to reset this value completely back to what it was, which is 1000, you hold the reset button as you power up, and bam, back to 0. So it's not that interesting or complicated in operation. So here's just a little bit of it working. So there you go. Kind of spinning this thing a little bit here. Well, moving it back and forth actually. It doesn't know the difference because there's only one encoder. If there was 2 Hall effects on there, you could actually tell direction if it's quadrature. But that's besides the point. So this is an old Olimex board I got from SparkFun. It uses an Atmega 2313. This code's using up about 99.2% of the flash and about 5% of the EEPROM. I removed some of the extra parts, including the relay and the buzzer, and tied into this terminal block, which is originally in the relay. It's kind of part of the reason I removed it. And this is something you could stick in a box, and you could just tie off these switches directly for whatever push buttons you want on your in your enclosure. And it runs off of this power supply here. I usually give it about 9 volts. It keeps the linear regulator from getting too hot. Switching power supply down to 5 would be great, though. Well, maybe a little bit above 5 because that switching regulator is about 6 or 7 would be fine. Or you can just go bypass it if need be. So anyways, I'll post the code up, and I'll post the data sheet for this device. I'm not going to post my changes to it because I don't have a scanner, so it's not the easiest thing to do, but I'll try and explain it. These buttons here are matrixed. That was kind of a pain. AVRs don't do so hot at changing inputs to outputs and outputs to inputs like quickly. So that was kind of a pain to read them. The next version of this actually has a bigger micro on it, and those pins aren't in a matrix, so you just read them, each pin at a time, And I think it also has USB, so it's a lot nicer than this old model, but this one does the job. So thank you for watching. If you have any questions, leave a comment or shoot me an email, and I'm probably going to put this in a nice box and put this up on Craigslist. So if you're interested, give me a shout.